All right, number 82 says, in an amusement park water slide, people slide down an essentially frictionless tube. Top of the slide is 3 meters above the bottom where they exit the slide, moving horizontally 1.2 meters above a swimming pool. What horizontal distance do they travel from the exit point before hitting the water? Does the mass of the person make any difference? So the first thing we need to do is determine the horizontal velocity at the bottom of the slide. So the energy at the top of the slide is just the potential energy, and it's given as VMGS, which is so the total energy at the top of the slide is the mass times gravity times height. And the energy at the bottom is 1/2 the mass times the velocity squared. So v is the velocity at the bottom of the slide, and according to the conservation of momentum, energy at the top is equal to the energy at the bottom. So we can go with the initial energy equals the ending energy. So we can substitute for this. Let's see. We can substitute for this mass times gravity times height. And for this, we can substitute 1/2 the mass times the velocity squared. That, if we solve for v, we get velocity equals the square root of 2gh. All right, so now that we know that, we need to determine the horizontal distance traveled from the exit point. And we can know that vertical distance traveled by an object under the influence of gravity looks like this. So here's that equation. Y equals the final position. Y of 0 equals the initial position. U equals the potential energy at the height. So in this case, we're at the bottom of the slide, so that'll equal 0 because there's no potential energy at the bottom. T equals time, and of course this is gravity times time squared. So we can know that time is equal to get time by itself is what we want to do. So we want to isolate the t. So by doing that, just say y minus y0 equals 0. G of t 2. So we're going to divide this by g, divide that by g. So these cancel. T is going to equal the square root of 2 times y of 0 minus y over gravity. Okay, so now we know that the horizontal distance traveled from the exit point is given as x equals velocity times the time. So here v is the horizontal velocity and t is the time taken to travel the horizontal distance. So x equals, I'm going to plug that in right there. X equals the square root of 2 g of h times 2y over g. That's what x equals we combine those two together, we get 2 square root of h times y of 0 minus y of 1. So now we substitute the height, which was, let's see, 3 meters. And let's see, y is going to be y of 0, going to be the initial position, so that was, let's see, 1.2. Oops. 1.2, is that right? And of course, y is just 0. And so we can solve that. Going to equal to equal 3. Let's see the calculator. Three times 1.2 equals 3.794 meters. Okay, so the final answer is 3.79 meters. And that is the horizontal distance traveled from the exit point before hitting the water. And does the mass make any difference? It does, because it would have changed all of these numbers from the outset